Hello and welcome to another one of D's ADD videos. Today we're going to be looking at an intermediate combustion example. We have an unknown sample that weighs 20 grams and the only possibilities for the elements are carbon, oxygen, and hydrogen in the empirical formula. We collect this much carbon dioxide upon combustion and excess oxygen and this much water. What is the empirical formula of this sample? So, if you remember, the first step in this type of problem in the combustions is to figure out the mass of the carbon and the mass of the hydrogen. The way you do that is you take your carbon dioxide mass and water mass and use your mole ratios, percent composition concepts to get your mass of each. So, here's the mass of the carbon dioxide. Here is the molar mass of carbon dioxide. I chose them to be the same so you could get an exact amount of carbon being 12 grams. But here's the crucial part right here. We know that for 1 mole of CO2, whenever the coefficient's 1, the subscript for the carbon is also 1. Okay? So that means there's a 1-to-1 ratio. However, for hydrogen, look, we have 1 coefficient for H2O, so that means for every 1 mole of H2O, there's 2 moles of hydrogen. That's why that's a 2 right there. Okay. If you multiply that out, you get these two masses for carbon and hydrogen. Now we sum these together and take away from 20 to get the mass of the oxygen in the sample. So here's that step right here. So add the 2, there's that, subtract from 20, here's your mass of oxygen. Finally, we are left with an empirical formula problem, so we have to get the moles of everybody by dividing by molar mass of each of the carbon, hydrogen, and now we found oxygen grams. There doesn't always have to be oxygen. If you add these two together and you got 20 grams, that meant that there was no oxygen in the sample, and all this oxygen from CO2 and NH2O came from the combustion reaction. Remember, we use excess oxygen whenever we're doing that. Remember that? So this was an excess. All right, so let's see that in action. So here are the masses of each one divided by the periodic table of molar mass. You're going to get these 3 moles in red. Then you divide by the smallest number of moles, which was for the oxygen. That gives you 1 there. 3.2. 1 and 3.2 are acceptable numbers, answers for subscripts, but 9.6 is not within plus or minus 0.2. So you have to multiply starting with 2, then with 3, then with 4, and it took all the way to 5 to get a number that was within plus or minus 0.2. So you're taking this 9.64 times those numbers. So because I multiply by 5 here to get that value, I have to do times 5 with the 1 and a 3.2 to get those other 2 subscripts. And as a result, you can get this empirical formula. Okay? Now, had you been given a molecular formula molar mass, what you would have done is found the mass of this empirical formula right here by doing 5 times the mass of oxygen, 16 times the mass of carbon, and 48 times the mass of hydrogen. Adding those answers up, that gives you the molar mass of the empirical formula. And once you got that molar mass, you take your molar mass of your molecular formula divided by that empirical formula molar mass you just calculated, and you take that constant times all 3 of these where the arrows are pointing. Make sure you check out the advanced example. Most importantly, practice, practice, practice. Thank you and have a nice day.